So this is another question. This is another number for the same year. This question 3A for the same year, same mass 102/mass 103. The question says we should find the dy dx given that y is equal to x to power tan x plus sine x to power cos x. Right, so the question is a bit looking complex, but very simple if you understand the concept. All right, so we are given y to be equal to x to power tan x, then plus sine x to power cos x here. Right, so we have x to power tan x and also have sine x to power cos x. Right, so we can let our u equal to this and then let our v equal to this to further deduce the problem for our understanding. So this is our u to be equal to x to power tan x, and then v to be equal to sine x to power cos x. So it means that my y is equal to u plus v. Alright, that's what it means. So furthermore, for the u part, we are going to be dealing with, let's deal with each of these section by section. So for the u section, for u equal to x tan x, we can take log of both sides. We can take natural log of both sides. Take natural log of both sides. If we do that, we'll be having ln u equal to ln x to power tan x. Alright, so from our basic knowledge of logarithm, we know that when you have log a to power b, it also means b log a. So from the same concept, from this point, we can also be having ln u to be equal to tan x ln x. Alright, so from our basic law of logarithm, we should understand how this thing came about. Alright, so we are going to be performing an implicit differentiation here. We're going to be performing an implicit differentiation here. So differentiating implicitly. We are going to be having this will be 1 over u du dx to be equal to, so this right hand side we are going to be using product rule because we have two functions here. We have tan x and ln x. So from our knowledge of product rule, it should be u dv, which is u, then differential of this plus this, and then the differential of this. So let's start with this tan x multiplied by the differential of this, which is going to give us 1 over x, then plus this, which is ln x, times, if you differentiate tan x, it is going to give you sec squared x. So it should be sec squared x. So it means that my 1 over u dx will be equal to 1 over x tan x, then plus sec squared x ln x. Right, so in making du dx the subject of the formula here, we'll be having du over dx equal to, we'll be having u into, we'll have 1 over x tan x plus sec squared x ln x. Right, so this is what we'll be having. Which is also the same thing as saying du over dx to be equal to u into tan x over x plus sec squared x ln x. Alright, so we already know the value of u. We said initially that the value of u is x tan x, so we can now replace the value of u here to have du over dx to be equal to x to power tan x here, then into tan x over x, then plus sec squared x ln x. Alright, so these are our du dx. So for v equal to sin x to power cos x here. Right, so what we just did was this. So we are doing for this now. Then at the end of it, we'll sum the two together. Alright, we're going to be summing the two together. So we'll be doing dv over dx of this with implicit differentiation too. Taking natural log of both sides. So if I take natural log of both sides, I will be having same ln v equal to cos x ln sin x. Alright, so if I take the natural log here, this one will have to multiply the whole expression here. That's why I got this. Then after, from this point, I will have to differentiate implicitly. Differentiating implicitly here, I will be having, if I differentiate v implicitly, I will be having 1 over v dv over dx here equal to, same here, I'll be applying product rule. So I'll have this, the differential of this, then plus this, and the differential of this. I'll have cos x plus, right, so I'll be having cos, this will be cos x times cos x over sin x. Alright, from chain rule, applying chain rule here, you obtain this. You're obtaining this. Alright, so I think we made a mistake here. Alright, so let's just redo this. Alright, so differentiating this implicitly, I'll be having 1 over v dv over dx to be equal to, right, so I will differentiate this. If I differentiate cos here, I'll have minus sin x. I will write this ln sin x, then plus, right, I will write this cos x, then I will differentiate this. If I differentiate that, I'll be having cos x over sin x, which means that 1 over v dv dx here will be giving me minus sin x ln sin x, then plus cos squared x, this time is cos squared x over sin x. Right, so this is what I will be obtaining. So making dv dx subject formula, I'll be having dv dx to be equal to v into minus sin x ln sin x plus cos squared x over sin x. Right, so because I know my v, so my v is sin x to power cos x, so I'll be having dv dx to be equal to sin x cos x here, then into minus sin x ln sin x plus cos squared x over sin x here. Alright, so I'll have to recall, because we've taken the differential of both, we'll now recall that y is equal to dv, right, so sorry, du over dx plus dv over dx. So we are done with this. It's just to substitute your answers there, and then that's all. So my dy, sorry, this is dy over dx is equal to this. So my dy dx now becomes my du dx was this, du dx, which is this. So I'll be having x to power tan x into tan x over x plus sine, is x squared x ln x, then plus my dv du, my dv dx, which is this. I'll be having sine x into cos x, right? Sine x to power cos x into minus sine x ln sine x plus cos squared x over sine x, and that becomes the answer.